Hello everybody and welcome to the shop. It's Friday morning and it is going to be a great day because look what came in the mail. This is amazing. I placed an order for this drive box, the control box for my lathe, Tuesday morning, maybe a little before 9. By about 9:30 I had a shipping notification that it was going to be shipped with a UPS tracking number. Wednesday evening, I just looked to see where it was at. I figured it would probably be Thursday, Friday before it got here. Wednesday evening it said, expected delivery, end of day, Thursday. I was a little skeptical, but I went to work and I'll be darned, by noon Thursday, this was setting on my desk. I'm super excited. It's a brand new motor. I got it from, it's a brand new control box for the motor. $60 for the box, $8.95 for the shipping. I got a brand new cable, a brand new box. I think that's all that's in there. And what we're gonna do is get this installed and get my lathe up and running again today. And I also have one more thing that I wanted to mention. On the old control box, I had so many people, and I've said thank you once, but I'm gonna say thank you again. There were so many people who contacted me with troubleshooting tips and ideas to try to get it fixed. And I think we've narrowed it down. I really believe it's either the MOSFET chips, probably the #1 thing that it is, or the capacitor. So what I'm gonna do is actually more than one person suggested this, I'm gonna go ahead and try to fix the old box because at this point, with the new one, I've got nothing to lose. So what we're gonna do is I'm gonna get this installed today, I'm gonna get the lathe running, and I'm gonna ask you guys, send me information about how to, the safest way to dissipate the charge on the capacitor. Then I am going to remove the capacitor from the board and we're going to test it. So send me instructions on, using my meter, what the best way to test it to know if that capacitor is any good or not. I'll test that on video for you guys. If the capacitor tests out bad, we'll order a new one and replace it. If it tests out good, then I'll have you guys give me information on the MOSFETs. Let's just do one at a time because I don't want to get everything too mixed up. But if you work with capacitors and know how to safely discharge them and how to properly test them, I'd love to hear from you. And before the end of the video, I will show you the capacitor in case there are any markings on it that will help you with what to look for when testing. Let's get over to the lathe and get this installed. I'm over at the lathe and this is my old control box. You can see that the front panels are pretty close. There's not much difference. It's a little different style on the box. Here's the back of it. You've got your main AC power in. You've got power out to the headstock, and then this is for the digital readout on the headstock. This is supplying power to the readout as well as the light, and it's a little different setup. This one, you got your power in, you got your power out to the headstock, and you've got your for your controller to read the readout on your RPMs. And it comes with this cable, and this cable is designed to plug in here, and then these two connectors you're supposed to hook to your light. You no longer run your light from the headstock. Now the light on this lathe, the bulb is not even in it right now. I don't use the light because I have so much light up above that I don't really need it, so I don't plan to use that. So we're just going to leave this dormant for now, but I'm going to go ahead and get everything else reinstalled under the lathe, plugged up, and we're going to give it a test run. The control box is attached to the lathe with 3 screws. What we're going to do is just slide this up underneath. I'm going to line up the screw hole. And we'll give this just a couple of twists just to kind of hold it in place so we can line up the others. Now that we've got the screws started, I'll go ahead and tighten everything down.
The front panel on this box is just plastic.
From the back side of the lathe, we'll go ahead and plug up the cord for the digital readout on the RPMs. That just plugs in right here, threads in. This is providing power to the headstock and power to my lathe. At this point, we're ready to test the lathe. For my test, I'm going to turn the potentiometer to the slowest possible setting. All right, look at that. Let me bring you around. We are currently running at about 1,500 RPMs. Nice and smooth, no surging. I need to check the belts. I was thinking I was on the lower setting, but I'll adjust the belts. There may be some adjustments that need to be made inside of the control box to control this, because it looks like the lowest possible setting should be about 500 RPMs up to about 3,800 on the belt settings I believe I'm on, and about 660 up to about 3,800 on the other set of pulleys. So I'm going to fiddle around with that for a few minutes, see if I can figure out why we're running at 1,000 RPMs or 1,500 RPMs, and I'll come back and show you what I do to correct that. I removed the cover from the pulleys and found that I had the belts on the larger pulley at the bottom and the smaller one at the top, which would increase my speed. So I reversed them. I put it on the smaller one on the bottom, the larger one on the top, and now when I turn the lathe on at its lowest possible speed, we're running at about 760 RPMs. That's still a little fast. I would like to be closer to 500. What I'm going to do is, there was nothing in the instructions as to how to adjust the speed. Let's take a look at what the maximum speed is here. So I think what I'm going to do is get on the phone with PSI's tech support, and I'm going to ask them what the best way for me is to dial my speed. And I know there are those little pot switches in there, or they're not called pot switches, I forgot what they're called now, but there are those little switches in there, or little dials in there that I can tweak, but I don't want to tweak them incorrectly. And see, the maximum setting here is only 1,600 RPMs. It should be up around 3,000. What I found out, I had to remove the box from the lathe, and inside of here there is an L for low, an H for high, and an F for frequency. And what you want to do is just take a flathead screwdriver, and we're going to adjust these. The gentleman told me that if I put the belt on the inside pulley closest to the headstock, that I can set the bottom end at about 500 and the top end at somewhere right around 3,000, which that's pretty decent for most of the type of turning I do, so I won't have to be worrying about changing the belts. So that's what we're going to do. I'm going to flip this on. I've got it turned all the way down the potentiometer. We're going to watch this come up to about 1,600 RPMs, and then I'm going to jump over here. I'm sorry about all the moving around, but I want to keep you in the loop for what I'm doing. I'm going to dial this clock. If I turn it counterclockwise, it speeds up. If I turn it clockwise, it slows down. And I'm just very slowly turning it. Okay. You can see that I'm already down around 480, 504, 503. I think that one's where I want it. That's my low end. Now I'm going to jump back over here. I'm going to wind this all the way up. And we're going to watch our top end. We'll let it top out. 2,800, 20. I'm going to give this just a tweak on the high. The second one here is the high. Get my hand out of the way, I'm sorry. Okay, counterclockwise slows it down. Clockwise speeds it up. So I'm winding it up 28, 28, 48, 2,900. All right, and now I'm running at about 3,040 RPMs. I'm going to turn the box all the way down. We're running right about 500. There we go. That's where I want it on the low end for finishing. And then we can wind it all the way back up. I'm going to step it up just a little bit. You can see it start to speed up. This is going to work out really, really well. Now, to do this, all I had to do was I removed the 3 screws that you saw me put in to mount the box. And then I removed 4 tiny little screws from the 4 corners of the bottom of the box. The box is currently upside down. You flip it over so you get your entry at the bottom of the box. I had this thing unplugged while I did this. I verified with him I could plug it in, so I plugged it in after I had it apart. Did my testing. You saw me do the testing live. I'll kind of zoom in a little bit. These are the dials that I used, and my lighting is really bleeding me out there. You've got your low end, your high end, and your frequency. Don't touch this one. He said, leave it alone, mess with these 2. That's all that I did, and I was able to dial it in right where I want it. I'm going to go ahead and get this button back up, and then I'll come back and talk about the capacitor on the other control box. As promised, guys, I want to give you a close-up of the capacitor. There it is. It's A1318. On the back side, I'm going to let you read it. Hopefully, I'm moving this slow enough to where you can get the information that you need off of it. I'll run back this way so you can see it one more time. What I would like from you, if you don't mind, is information on how I can safely discharge this capacitor. It only has 2 contact points, so I can very easily desolder those. I've got a solder sucker, not a problem. I can get it off there to test it. The other device I'm interested in is this little black device here. It's only got 2 contact points. I can remove it as well. And you can see it says NTC, Nancy Thomas Charlie, 3D-20. Interested in that one. So what I would like is if you could tell me how to safely dissipate the charge on this, and then what the best way with my meter to test this and to possibly test this device are. I'd like to start with those 2. If they're good, we'll put them back on the board, and then we'll take a look at the MOSFET chips and see what they look like. Other than that, I'm really I'm excited about the possibility of replacing these parts and maybe getting this board working. And I've got one more announcement about this board. Let me flip the camera around and I'll tell you. My lathe has a DC motor, and you've got your positive and negative leads coming into the motor, and the orientation they're in determines which way the motor spins. Flipping that orientation should reverse the motor. I've been talking to an electrician at work about this. If I get, I think it's called a dipole switch, to where you wire the switch up to where the leads come in, you know, black and white on top and black and white on the bottom, just the reverse. You can flip the switch one way or the other, and it should reverse the direction of the motor. So if we can get this working, because I've got nothing to lose on here, we may spend a few dollars on parts, but it's worth it just for the fun and the education. But if we can get this working, I'll look into purchasing a dipole switch. Now, they're rather expensive, so that may take me a little longer to acquire, but we'll purchase one of those, attach it up to this board, pop it on the lathe, and see if we can reverse the direction of the motor. I thought that might be kind of fun to try. I've talked to a number of people, and they've looked at the motor numbers and say it should work just fine. It's just a matter of, you know, getting the juice flowing in the opposite direction. So I really want to thank you for all your help so far. I want to thank you in advance for any help on these 2 items. We'll talk about the MOSFETs later if these turn out to be good, but I look forward to hearing from you. Whatever I try, I will try on camera. That way you can see the results. So be sure to tell me the right way to do it. Don't make me look too dumb. But we'll try it on camera. It should be fun. I really appreciate it. Thank you for hanging out with me in the shop. I want you to know that you are always welcome in my shop. Come back and see me again real soon, and maybe next time we'll be able to fix this board.